Now that we've got our base drawing completely designed, made into 3D, and we've added our art onto the front of it, now we're ready to start programming. And before we program anything, we have to know how we're going to machine it. And the way that I'm going to machine this block is I'm going to load it up into a vise and cut the backside first. I'm going to face it, put in all the holes, add a chamfering program. Then I'm going to flip the block over, bolt it to a fixture from the back, and then from the front side I can go ahead and face it, cut the slots in here, and cut the outside of the block and then do my engraving. So that's my process for machining. So let's go ahead and get started with the programming. Now, before I can program this part, I have to create a level, or sorry, a plane on the back side of the part, and that plane is going to be my XYZ0 when I go to the machine. So to do that, I like to work off the center of the block on Op1. Now working off the center of this block, I don't know it and I can't select it because I have a solid. Well, in able to create this solid into the lines that I need, I'm going to go to wireframe and I'm going to push the curve all edges button. Select my solid and selection, green check, and now you can see I have lines here. Everything is turned into a line, and lines I can use for chaining and other things. So now I'm going to go ahead and create a line, and I'm just going to go from the center point of this radius to the center point of this radius. Now I have a line on the part, and I know that the very center of my line, or the midpoint, is the very middle of the block, and that's where I want to create my plane. So if I go to planes and I push the plus button, I can click dynamic, and now my mouse becomes the plane that I want to create. I'm going to snap it to the very midpoint of this line, and you notice that my plane is going the wrong direction, so I'm going to click on the green arc and I'm going to rotate it 180 degrees. Press enter twice. Now this is my new plane. It's the XYZ0 is in the top center of this back of the part, and that's where I want it. I'm going to call it Op1, and I'm going to push green check. Now if you go to my planes menu, you'll notice that top is still the active plane. Well, if I bring my work coordinate system, my construction plane, and my tool plane all down to Op1, now this plane is active and ready to be used. So with this plane active, I'm going to go ahead and create my machine. So we'll go to Machine, Mill, and Default. Now if I come down to the Toolpath tab, you'll see I have a machine created. So the first thing we're going to do is we're going to go in and we're going to set up the tool settings. In my tool settings, I want to assign tool numbers sequentially and warn of duplicates. So assigning them sequentially will mean any tool I grab out of the library will become, the first tool will be 1, the next one 2, the next one 3, regardless of what the tools in the library are. Warning of duplicate numbers, it makes it so that I can't have the same number twice. Now, I'm going to override defaults with modal values for my clearance height, retract height, and feed plane. So what this is going to do is it's going to grab information out of the tool library, and for my feeds and speeds, I'm going to go from material, and it's set at aluminum 2024, which is fine. We are going to be machining this part out of aluminum. I could change it to the 6061 if I want to, but 2024 is going to be fine for what we're doing. I'll end up changing most of my feeds and speeds manually as we go. So now we'll go to stock setup, and in the stock setup over to the right here, this is the actual size of our raw stock. So my stock is going to be 6.2 long, 3/4 inch thick, and 4 inches wide. It's going to be the stock that I buy. Now over here to the left, this is where the origin actually sits in the stock. So if I don't change this, it's going to move my stock box somewhere it doesn't want to be. So I'm going to make this 0, 0, 0. And that'll make my stock actually positioned in the center of the part. I'm going to push display stock, green check. And now you'll see this little red dashed line around here represents my raw stock. Okay, so with that done, now I'm ready to start programming. Now the first thing I'm going to do to this part is I'm going to face it with a 1/2 inch end mill. So I'm going to click the facing tab. And this dialog here is the chaining. It's asking what is the boundary that I want to face. So this is selected on a closed chain here. So I'm going to go ahead and I'm going to click this blue line. Now you'll notice that the blue line, or that it chained my part completely all the way around. If it did not, you'll have to continue to click around the part until it closes the chain. Green check. The tool that I want to use, I'm going to select tool from library. You will have to go to filter, and then the easiest thing to do is to hit none. Now I want to use a 1/2 inch flat end mill, so I'm going to click my end mill flat, green check, and then this gives me a list of all of the end mills in this generic tool library. So I'll go ahead and grab the 1/2 inch flat end mill, green check. So that becomes tool number 1. My spindle speed. I normally calculate with surface footage, but when I'm cutting aluminum, in most cases I'm going to hit the maximum spindle speed of my machine. On this particular tool, I want to run 5,000 RPM, which is going to max out my little Haas mill. So 5,000. And then my feed rate, when I'm roughing, I like to go 1% of diameter. And when I'm finishing, I like to use 0.5% of the diameter. Well, in this case, it's going to be a finished pass. So 0.5% of 1/2 an inch is 0.0025. So that'll be my chip load. Under cut parameters, I want this program to zigzag so that it goes back and forth. It doesn't lift every pass. And then I'm going to leave 0 stock allowance on the bottom. I'm not going to use depth cuts. That would be multiple passes in the Z. My linking parameters is set to where it tells it the level that it's going to cut at. So what you have to look at here is the difference between absolute and incremental. Anything that I use that is absolute is coming from the origin in the Z. Anything incremental is coming from the chain that I selected. In this case, my chain and my origin are at the same Z-plane, so it doesn't matter if I use absolute or incremental. So we're going to leave that alone. Well, the other thing is I'm going to come down to the coolant and I'm going to turn my coolant on, green check, and you'll see that it takes a nice facing pass across the top of that part. Now, to make this facing pass so I don't see it anymore, I'm going to come over here and I'm going to toggle display button, which is these 3 kind of wavy line looking button. This will turn any toolpath that is highlighted on or off. So I'm going to go ahead and turn that off. Now, with my part faced, I want to go ahead and center drill the holes. So I'm going to use a drill toolpath. It's asking me now to select the holes that I want to drill. So make sure you're clicking on the very top hole and snapping to the center point. Now it does not matter which diameter holes I select because I want to center drill everything, or spot drill. Green check my holes. Go into my tool library, select tool from library, filter, and then what I'm going to do is I'm going to select a spot drill. Green check, turns all my spot drills on. I'm going to use a 3/8 spot drill. Green check, you can see now tool number 2 is a 3/8 spot drill. Same thing, I'm going to run this at 5,000 RPM and 0.0018 is 0.5%. So 5,000 RPM, 36 inches a minute. That thing's going to be cruising, but it'll do a good job at that. cut parameters. Right now we're using just the drill and counterbore. This is a straight in, straight out. That's what we're going to do with that spot drill. My linking parameters is going to be the depth, and we're just going to go 150 thousandths deep. Make sure your coolant is turned on. And you can see that it created a tool path that is just going to spot drill all of those holes. Now our next tool path is I want to go ahead and drill the 5/16 holes, which are the tap drill for all of these holes here, because they're all going to be 3/8/16 tapped. So we're going to select a new drill, and I'm going to start with these 4 outside holes. Even though these top 2 holes are also 3/8/16, they're going to go all the way through, so we need to make them in a separate program. Select those 4 holes, green check. In my tool, I'm going to go to my library, filter, and what I want to do is I want to grab the actual drill this time, right above my spot drill. Green check. So I'm going to go find a 5/16 drill. I know it's 312. So right here, 312, 5/16 drill, green check. Now, my drilling feeds and speeds are a little bit different because I'm not using carbide. I'm going to be using high-speed steel drills. So I'm just going to go with 200 surface footage because we are cutting aluminum. And then I'm just going to go 1% of the diameter, which is 0.03. Sorry, 0.0031. So we're at 2444 RPM, 15 inches a minute. Under our cut parameters, I'm going to peck drill these holes. So I'm going to change it to peck drill, and I'm going to take a 100 thousandths peck for each pass. In my linking parameters, I'm going to put the depth. So I'm going 650 deep. This part is 750 thick, and I do not want to break through into the front side with these drilled holes. So 650 deep. My coolant, as long as I keep drilling, should continue to stay on until I switch to a different tool path. But I always like to check it. So that drilled those 4 holes. Now, with these next 2 holes, I'm going to be using the same drill, the same parameters, only I'm going to send it through. So what I'm going to do is I'm just going to copy and paste my tool path. Now it brings over all the parameters with it. So down here under geometry, it brings me up here, and I can go ahead and delete all of these holes now, and I can add in the 2 holes that I want it to cut. Green check, and now if I go into my parameters, I'm going to go into my linking parameters, and I'm going to send this all the way through the part. So we're going to go minus 800, but then I'm going to turn on tip comp, and this will guarantee that the tip of the drill goes all the way to the diameter of the drill, and that breaks through the part. So I typically only use tip comp if I'm drilling a through hole. So we'll green check that. And now you'll notice there's a red X in here, and it didn't calculate these holes. That's because it's considered a dirty program in Mastercam. You have to actually tell it to calculate dirty programs. So this little button right up here, regenerate all dirty operations, I'll click that, and now you'll see that it's drilling that toolpath all the way through. Now I have one more hole to drill, and that's this center hole here with a 1/2 inch. So we're going to make another drill program. Green check. Select tool from library. We're still under drills, so I can just go down until I find the 1/2 inch drill. Green check. We're going to stay at 200 surface footage. 5/1000 chip load for my 1%. Notice we're on tool number 4 now. Everything else should be good. My linking parameter is already going 800 deep, which go all the way through the block. Cut parameters is set to Peck. Coolant should be on. It should be all we need to do, and there we go. We're drilling all the way through that. So now with all my holes drilled, I'm going to go ahead and I'm going to machine the counter bores in the 4 outside holes. So we will go ahead and turn off all of our tool paths. So the easiest way to select everything is to hit this little teal 4 circle button here, which will select everything, and then I can go to the wavy lines button, turn everything on, turn it all back off, so I don't have to look at it. Now the easiest way to cut these holes is going to be using a contour tool path. Contour, I'm going to select the 4 holes as my chain, green check. My tool, I'm going to use a 1/4 inch end mill, filter, none, and then I'll grab flat end mill, 1/4 inch flat end mill, check mark. We're going to be running it at 5,000 RPM, and then 0.0012 is the finish feed rate. It's 0.5% of my diameter, or my chip load, which gives us 24 inches a minute, which is good. Under cut parameters, we're not going to change anything this first time around. We're going to see what it does, whether it goes to the inside or the outside of the line. Depth cuts. Okay, I'm going to tell it to take a 20 thousandths depth cut for every pass. And my lead in, lead outs right now, I'm just going to turn them off. Now my linking parameters, the top of the stock is 0. My depth is going to be minus 0.25. Once again, it doesn't matter if this is absolute or incremental because my chain that I selected is the same Z as my origin. Coolant, turn my coolant on, green check, and you'll see that it cuts a nice little counterbore program in there, 250 thousandths deep. But you'll notice this one cut on the wrong side of the line, but the rest are on the right side of the line, the inside of the hole. So the issue we have is when we created our chains, the direction of the chains, and I'll show you what I mean. So if I go to my geometry and I look at my chains, you look at this green arrow, how it points in, points in, points in, and this one points out. So what do I have to do is select that chain, right click on it, and reverse. Now you'll see that it points in. Looks good, green check. That program becomes dirty. We regenerate. And now all of the holes are being counterbored in. Okay, so with that done, we're going to go ahead and tap all of my 3/8/16 tapped holes. Actually, before we tap, we're going to go ahead and chamfer everything. So, to create a chamfer program on sharp edges, the best way I find to do it in Mastercam is to actually use a contour and then use negative stock allowance to create the chamfer. So, let's go ahead and do that. So, we're going to go ahead and create a contour program for my chain. I'm going to select the outside and all of the inside holes. And we may have to go back and reverse some of these later. It looks like we're gonna, but we'll go ahead and make the program first. I find that's a little easier. Oops, and that one. Green check. The tool we're gonna use is our same 3/8 spot drill that we used earlier. It's on a 45-degree angle. So we're gonna leave everything alone in here. I'm gonna turn my depth cuts off. Put my linking parameters, my depth, I'm going to go minus 0.1. Oops, minus 0.1. 100 thousandths deep. And then, sorry, my cut parameters under stock to leave on the walls, I'm going to shift this tool in by leaving a negative stock allowance. So the way you have to think of it is 187 radius tool. So the most that I can leave negative is 187. I don't want to go that far, so I'm going to go minus 0.120. Hit the green check mark, and you'll see that this toolpath is just on the outside of here. Now if I actually turn on my toolpath and we look at this tool, you'll see the chamfer that it's going to create. So I'm going to verify it, I'm going to push play, and then I'm going to stop it. Now you can see that that toolpath is cutting a nice light chamfer into that part. And that's what we were looking to do. And to adjust your chamfer, you would give it either a larger negative stock allowance or give it a deeper Z in your linking parameters. Okay, and I'm going to look at my holes, and I'm going to see that 1, 2, 3, 4 of these holes are cutting on the wrong side, so we're going to go ahead and reverse those right now. Go into my geometry, look at my arrows, in, out, 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 out. These 4 all are going out the wrong direction. So let's go find all of those chains and reverse them. And the last one here, reverse. Green check, calculate dirty. Now we have everything chamfered. So all that's left is to go ahead and tap our holes. So I'm going to turn this toolpath off. To create a tapping program, we're still using the drill icon. Selecting the 2 holes. So the first thing we'll do is we're going to tap these 4 outside holes. Green check, tool. Select tool from library. We're actually going to make sure that we grab a right-handed tap. Should say tap RH on there. Green check. We're using a 3/8/16 tap. Becomes tool number 6. I always use 100 surface footage for my taps. Okay. Or sorry, 25 surface footage for my taps. And then, which gives me 254 RPM, which is pretty decent tapping speed for rigid tapping on a CNC machine. And then you don't worry about the feed rate. That came in from the pitch of the tap in the tool library, so don't change that once it comes in. Cut parameters, we have to come in here to where it says Peck Drill, and we have to change it to tap. Okay. Linking parameters, we're going to set the depth. Now I drilled these holes 650 thousandths deep. I cannot hit the bottom of the hole with my tap during the rigid tapping cycle, or it will break the tap. Okay, so I'm going to go minus 0.550. That gives 100 thousandths of clearance. If you want to bottom these taps out a little further, you can do it by hand afterwards. Try to get that extra thread or so on there. I do not want a tip compensation on. That's going to send it deeper. And then I want to make sure my coolant is on for this tap, yes. If you don't want to have your coolant on, you want to put an M00 in your program and then put some oil in the holes, that's okay too. So there, it tapped those holes. Now I'm going to copy that program, paste. I'm going to go ahead and change the geometry to these other 2 3/8/16 tapped holes, and I'm going to make sure these do go through the part. So I'm going to go back into my linking parameters, and I'm going to tell it to go 900 deep and turn my tip cop on. So you want to make sure you have at least 1 inch of threads on your tap, which most 3/8/16 taps should be able to go that deep. That'll tap these holes all the way through. This is what you want because we're actually going to be bolting in our pins from the front side. So calculate that. Now our part is fully programmed. So we'll go ahead and select everything, turn it all on, and do a quick verify. Facing, spot drill, peck drill with a 5/16 drill, peck drill with a 1/2 inch drill, counterbore, chamfer, and then tap. So that's that video. Come to the next video to see how we're going to program Op2.